Right now, a patch of ocean bigger than the United States is quietly heating up. You cannot see it from your window, but it is about to reshape your summer, your weather, and maybe the hottest year in all of human history. Scientists call it El Niño. It begins as warm water off the coast of Peru. The winds that hold the Pacific in place go weak, and the heat spreads until the whole planet feels it. We are going to follow that heat across the ocean. You will see coral reefs turn white and starve. You will watch deserts drown under sudden rain. You will learn why powerful hurricanes go silent and why the year ahead could shatter every temperature record we have ever kept. If our strange, powerful planet makes you curious, hit like and subscribe. The Pacific is already shifting. Let's begin. 400 years ago, on the coast of Peru, fishermen felt the ocean change under their boats. Most years the water there stayed cold, even under a burning desert sun. That cold water was full of life. Nets came up heavy with silver fish, enough to feed whole towns. Life on that coast ran like clockwork, season after season. Then, every few years, something strange happened around Christmas. The water turned warm, and when it warmed, the fish simply vanished. The nets came up light. The catch dropped so far that fishermen would pull their boats onto the sand and wait. They spent those weeks fixing gear and sitting with their families, because the sea had nothing left to give. They needed a name for it. Since the warm water arrived near Christmas, they named it after the baby at the centre of that holiday. In their language, they called it El Niño, which means the little boy, and it also stood for the Christ child, a gentle name for something that would one day shake the entire planet. Back then, the fishermen thought it was a local problem. Warm water, empty nets, a hard season, then back to normal. To them it felt like bad luck that visited their stretch of coast and nowhere else. They had no way to know how wrong that was. That warm water off Peru is the visible tip of something enormous. It reaches across the widest ocean on Earth. It can flip rain into drought on the far side of the world. It can silence hurricanes, dry out rainforests, and help push a whole year into the record books as the hottest ever measured. Here is how big we're talking. The warm belt that forms during one of these events can stretch about 5,000 miles across the Pacific. That is roughly the distance from New York all the way to Hawaii and then some. All of it warming at once from one shift that starts small. For hundreds of years, nobody connected the dots. Sailors in one country saw floods. Farmers in another saw their fields crack and dry. A coast on one side of the ocean drowned while a coast on the other side burned. Each place thought it was suffering alone, cursed by its own bad weather. The truth is that these disasters were cousins. They were all children of the same warm water the Peruvian fishermen had named. One event spread across half the globe, wearing a different mask in every country it touched. Scientists are certain of this today. They have watched it happen with buoys, ships, and satellites. They can measure the exact patch of ocean where it begins and trace its fingerprints thousands of miles away. The link is proven, tested, and real. And it is happening again in 2026, right now as you listen. The little boy has returned, and this time it is growing fast. But to understand why warm water is such a big deal, you first have to understand why that Peruvian coast is normally so cold in the first place. A desert sits right on the shore. The sun beats down all year. By every rule you think you know, that water should be warm. Something powerful keeps it cold, and that something is a hidden river flowing through the sea itself. There is a river inside the ocean, and it is running cold. You cannot see it from a boat. It has no banks and no shoreline, but it is real, a vast current of cold water sliding up the western edge of South America, hugging the coast of Chile and Peru as it goes. Scientists call it the Humboldt Current, and it is one of the reasons that stretch of sea is so alive. Think about how strange this is. The land right beside it is desert. Parts of the Peruvian coast can go years without a drop of rain. Some spots there are among the driest places on the whole planet. By every instinct, the sea beside a hot desert should be warm and lazy and empty. Instead, it is cold and crowded with life. The cold water is the key. Cold water can hold more of the stuff that living things need, and this current drags that richness up from the deep and along the coast. It carries the raw ingredients for one of the greatest feasts on Earth. Here is the chain. The cold, rich water feeds tiny floating plants, so small that millions could fit in a single drop. Those tiny plants feed clouds of small fish. mostly a little silverfish called the anchovy. The anchovies feed bigger fish and seabirds and seals and even whales. Pull out the cold water and the whole tower of life comes crashing down. How rich is it? This one cold current helps power a fishing zone that, in a good year, can pull in more fish by weight than any other single fishery on the planet. From a coast that looks, from the air, like a strip of empty sand. The people there built their lives on this cold gift. Fishing towns, markets, whole ways of living, all standing on the back of that hidden cold river. For as long as the water stayed cold, the fish stayed thick and the town stayed fed. The cold is the engine. It is the thing that turns a desert coast into a place bursting with life. And like any engine, it can stall. Now here is the part that should stop you. This cold engine off the coast of Peru is controlled from thousands of miles away. The water piling up on the far side of the ocean, near Asia, quietly decides whether the cold near Peru stays strong or shuts down. That may sound impossible. How can something happening near Indonesia reach across an entire ocean and switch off the cold water off South America? It is one of the strangest links in all of Earth science, and it is completely real. The answer lives in the wind. Steady winds blow across the top of the Pacific day after day, year after year. Those winds are like an invisible hand pressing on the whole ocean. They decide where the warm water goes and where the cold water is allowed to rise. As long as those winds keep blowing the right way, Peru stays cold and the fish stay fat. But the moment those winds falter, the cold begins to fail and the little boy stirs awake. To see how a puff of wind can move an entire ocean, we have to travel across the Pacific to a place where the warmest seawater on the planet is hiding in plain sight. Picture the Pacific Ocean from high above, calm and blue, wider than any other ocean on Earth. It looks still. It looks like it should just sit there. But across its middle, along the equator, a steady wind is always at work. These are the trade winds, and they blow from east to west, from the Americas toward Asia almost every single day. The trade winds are patient. One gust does nothing, but blow across the same water for months and years, and you start to push the ocean itself. The winds drag the warm surface water along with them, sweeping it slowly westward, piling it up on the far side of the sea near Indonesia and Australia. You can try a tiny version of this at home. Blow steadily across a bathtub of water. The water climbs up at the far end and sinks a little at the end near your face. The Pacific does the exact same thing, only the tub is thousands of miles wide. The result is a lopsided ocean. On the western side, near Asia, the warm water stacks up. The sea there is actually higher than it is off South America by more than a foot. That may sound small, but it stretches across the whole Pacific, so it adds up to a staggering amount of warm water leaning against Asia. Meanwhile, on the eastern side near Peru, the warm surface water keeps getting pushed away. That lets the cold water from below rise up to take its place, so the west stays warm and high, and the east stays cool and rich. West warm, east cold, held in balance by the wind. This is the normal Pacific. Scientists call it the neutral state, the everyday setting the ocean returns to when nothing unusual is going on. Trade winds blowing, warm water in the west, cold water feeding the east, and most of the time it holds. The winds blow, the balance stays, the fish off Peru stay fat, the rain over Indonesia stays heavy. Year after year the machine hums along. But look closely at what is really going on here, because it is a little bit frightening. All that warm water piled up in the west is being held there by nothing but wind. It is leaning against Asia like water held back behind an invisible wall of moving air. The warm water is not happy up there. Water always wants to spread out flat and level. The only reason it stays piled in the west is that the trade winds keep pushing it and pinning it in place. Take the wind away, and that whole mountain of warm water will want to come rushing back east. Think of it like pulling back a slingshot. The steady winds are your hand holding the band stretched tight. As long as you keep pulling, nothing flies. There is a huge amount of stored energy sitting right there, quiet, loaded, waiting. So the calm Pacific you pictured is a trick. It looks peaceful, but it's really a loaded spring, wound up a little more with every day the trade winds blow. Most years the spring just stays wound. Then, every few years, the winds relax and the whole thing lets go. Before we watch it snap, you need to see just how much heat is stored in that western pile. Because it is not ordinary warm water. It is the hottest large patch of ocean anywhere on Earth. Near Indonesia, hidden in plain sight, sits the warmest large body of seawater on the planet. Scientists call it the Western Pacific Warm Pool. It is a giant zone of ocean where the surface stays above 82 degrees Fahrenheit almost all the time, warm as a heated swimming pool stretching across an area bigger than the whole United States. Remember, the trade winds spent years shoving warm surface water westward until it stacked up here. All that piled water bakes under the tropical sun and soaks up heat like a sponge. The result is this enormous pool of warmth, the beating hot heart of the Pacific. Now warm water does something important. It heats the air right above it. That warm wet air becomes light and starts to rise, the same way steam lifts off a hot bath. As it climbs high into the sky, it cools, and the water in it turns into towering clouds and heavy rain. So the warm pool is a rain factory. Some of the biggest, most reliable thunderstorms on Earth live right above it. This is why places like Indonesia and the rainforests near it are so wet and green. The warm pool feeds them, day after day, storm after storm. Here is a way to picture it. Imagine a giant stove burner switched on under that part of the ocean. The heat rises, the air churns, and rain pours down over the countries nearby. That single warm patch of sea sets the weather for a huge chunk of the planet, and the warm pool reaches far. The heat it pumps into the sky helps steer winds and weather well beyond the tropics. When this pool is doing its normal job, the world's weather settles into its usual rhythm. Rain, where rain belongs. Dry, where dry belongs. The scary part is where all this heat is sitting, and how it is being held. This is the very same warm water that the trade winds pinned against Asia. It is the loaded end of that slingshot from before, a mountain of the hottest ocean on Earth, kept in place by nothing but steady wind. As long as the winds hold, the warm pool stays put right over Indonesia, doing its job. The rain falls where it always has, the balance stays, but warm water is restless. It wants to spread. And this is the greatest pile of warm water anywhere on the globe, leaning westward, waiting for its chance to move. If those trade winds ever weaken, this warm pool will not sit politely in place. It will begin to slide back east, across the open Pacific, carrying its rain factory with it. And when the rain factory moves, the countries that depended on it are left dry, while places that were dry get drowned. That single shift, warm water sliding east, is the whole story of El Niño in one sentence. Everything else, the floods, the droughts, the silenced hurricanes, the record heat, all of it flows from this pool of warmth escaping its cage. So the question becomes simple and huge. What keeps this warm pool from spreading out already? What holds the heat pressed against Asia instead of letting it float free across the ocean? The answer is the wind on top, and also a hidden shape deep under the surface, an invisible slanted line in the water that most people have never heard of. Find that line and you find the trigger. Dive down into the ocean and, at a certain depth, you slam into an invisible ceiling. Above it, the water is warm, lit by the sun, the part swimmers and fish enjoy. Below it, the water turns cold and dark and heavy, and the switch between them is shockingly sharp. Swim down slowly and you can pass from warm to cold in the space of a few feet, like stepping from a warm room into a freezer. Scientists call this boundary the thermocline. It is the dividing line between the warm surface water on top and the cold, deep water below. It works a lot like oil floating on water in a glass. The lighter, warmer water rides on top. The heavier, colder water sinks beneath, and there's a clean line where they meet. Here is why this line matters so much for El Niño. Across the Pacific, the thermocline is tilted. Remember, the trade winds pile warm water up in the west. So over there, near Indonesia, the warm layer is thick and deep. The cold water is buried far down, sometimes 500 feet below the surface. The warm blanket on top is heavy and thick. On the eastern side, near Peru, the opposite is true. The warm surface layer is thin. The cold water sits close to the top, sometimes only 100 feet down or less, almost close enough to touch. The blanket there is thin and worn. So picture the thermocline as a slanted line under the sea, deep in the west, shallow in the east. That tilt is a picture of the whole system's balance. As long as the trade winds blow hard, the tilt stays steep. Warm water locked in the west, cold water poised in the east. This slanted hidden line is like a memory. It stores the record of every day the winds have been blowing. Steep tilt means the machine is wound up tight and working normally. Now, here is where it gets tense. That tilted line wants to level out. Water hates being held on a slant. The only thing keeping the thermocline steep is the wind pushing on the surface above it. So think of a pan of water you have been tilting toward one end, and then you suddenly set it flat. The water rushes back the other way, rolling across to the far side, sloshing back and forth. The tilted thermocline is exactly like that. Let the winds relax, and this whole slanted boundary will slosh back toward the east. When it sloshes, the warm layer in the east suddenly gets thick. The cold water that was sitting close to the surface off Peru gets shoved down, deep, out of reach. And that one change flips everything. Because the shallow cold water off Peru is what feeds all that life we talked about. It is the source of the feast. When the thermocline sloshes east and drives the cold water down, the feast has no fuel. For now though, in the normal ocean, that cold water still sits close to the surface off South America, right there in the light, ready to be used. And the ocean has a beautiful trick for pulling it up into the sunlight where life can reach it. That trick is called upwelling, and it is the reason a desert coast can feed millions of people. And let's see how the ocean breathes. Along the coast of Peru, the ocean does something that looks almost like breathing. Down in the deep, the water is cold and dark, and it is loaded with something precious. Over thousands of years, dead plants and animals sink down and rot, and they release a kind of natural fertilizer into that deep water. It is rich, life-giving stuff. The only problem is that it is stuck down in the dark, far from the sunlight that living things need. So how does it get up to the top, where it can do some good? The wind pulls it up. Here is the trick. The trade winds and the coast work together to push the surface water away from the shore, out toward the open sea. When that top layer slides away, it leaves a gap, and nature hates a gap. Cold water from below rises up to fill it, climbing toward the surface, carrying all that deep fertilizer with it. Scientists call this upwelling. Picture a straw pulling a drink up from the bottom of a glass. The wind is the mouth on the straw, and the cold, rich water is the drink rising up from the deep into the light. Once that fertilizer reaches the sunlit surface, the magic happens. Tiny floating plants explode in number, turning the water green with life. Those plants feed the anchovies, the little silver fish we met before. The anchovies feed the tuna, the seabirds, the seals, and on up the chain. This is why a desert coast can feed the world. In a strong year, the fishermen of Peru have pulled up around 10 million tons of anchovies in a single season. 10 million tons of fish from one strip of coast, all built on cold water rising in the sunlight. Those fish get ground into feed that helps raise chickens and farmed fish across the entire planet. A meal on a plate in another country can trace its way back to this one cold, upwelling sea. So upwelling is one of the most important tricks the ocean knows. It is the pump that lifts the deep riches up to the surface and turns them into food, and it runs on two things working together: cold water sitting close to the surface and wind to pull it up. Now you can feel the danger. This whole pump depends on the cold water being near the top, ready to rise. It depends on the thermocline staying shallow off Peru, and on the trade wind staying strong. Take either one away and the pump breaks. If the winds weaken, there is nothing to pull the deep water up. If the thermocline sloshes east and shoves the cold water far down, then even when water does rise, it is warm and empty, carrying no fertilizer at all. The straw is still there, but now it only sips warm, lifeless water. When that happens, the green water turns clear and blue and beautiful and dead. The tiny plants starve, the anchovies flee or die, and the tuna, the birds, the seals, all the way up the chain, go hungry with them. A feast that fed millions can empty out in a matter of weeks. The switch that flips all of this is the wind. So far we have talked about the trade winds as steady and reliable, but every few years, for reasons scientists still argue about, those winds do something they are supposed to never do. They stop. It begins with a hush. For years, the trade winds blow their steady path across the Pacific, west, 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 holding the whole system in place. Then, every few years, they fall quiet. Sometimes they simply weaken. Sometimes, in one part of the ocean, they actually turn around and start blowing the wrong way, from west to east. That backward puff has a name. Scientists call it a westerly wind burst. It can last just a week or two. It can cover only a slice of the ocean. It seems far too small to matter. And yet one of these little bursts can be the spark that lights the whole thing off. Here is the honest truth, and it is one of the biggest open questions in this entire story. Nobody knows for sure what makes the trade winds falter in the first place. Scientists have ideas, Maybe a run of storms near Indonesia, maybe the ocean's own slow rhythms, maybe a mix of things lining up by chance. But the exact trigger, the thing that tips a normal year into an El Niño year, is still a genuine mystery. Researchers are working on it right now, and they will tell you plainly that they cannot yet predict that first spark with confidence. What they do understand is what happens next, once the winds let go. Remember the slingshot. For years, the trade winds have been pulling it back, piling warm water against Asia, holding the thermocline on its steep tilt. All that stored energy has been waiting. The winds were the hand holding it tight. When the winds weaken, the hand opens. The mountain of warm water in the west, which has been leaning against Indonesia this whole time, suddenly has nothing holding it back. And warm water always wants to spread out and level off. So it starts to move. It begins to slide back east, across the open Pacific, toward the Americas. Picture letting go of one end of a long tilted tray of water. The water does not creep. It rolls, gathering as it goes, sweeping across to the low side. That is the Pacific once the winds fall quiet. A whole ocean of warmth, released, heading east. And here is the cruel twist that makes this thing grow. As the warm water spreads east, it warms the air in the middle of the ocean, and that warm air weakens the trade winds even more. Weaker winds let even more warm water slide east, which weakens the winds further still. The system starts feeding itself. A small nudge becomes a shove becomes a surge. This is why a tiny wind burst that lasts 2 weeks can grow into an event that grips the planet for a year. Once the loop starts turning, it powers itself. Scientists are certain about this feedback loop. They have watched it wind up, over and over, in event after event. The mystery is the spark. The loop that follows is well understood and very real. So the winds go quiet, the hand opens, and the warm water begins its long march east. But that march is not a simple, slow spread across the surface where you could watch it drift. The warm water travels in a hidden form, a giant wave rolling deep beneath the surface, crossing almost the entire ocean while barely lifting the water on top. Most people have never heard of it, and it is one of the most powerful things moving through the sea right now. Right now, a wave taller than a skyscraper could be rolling across the Pacific, and no ship on the surface would ever feel it. When the trade winds weaken and the warm water starts sliding east, it does not just smear across the top of the ocean. It travels as a giant, slow bulge deep under the surface, moving along the equator like a runner on a track. Scientists call these Kelvin waves. Picture a wave and you think of the beach, the kind that curls and crashes. A Kelvin wave works in a stranger way. Down in the deep Pacific, it can be hundreds of feet tall, a swollen bulge of warm water pushing the thermocline down as it passes. Yet up at the surface, it lifts the sea by only a few inches. You could sail right over the top of it and never know a monster was passing beneath your hull. Here is how to picture it. Imagine a long garden hose lying full of water. You lift one end just a little, and a slow bump travels down the length of the hose to the other side. The Pacific is that hose, thousands of miles long, and the Kelvin wave is the bump carrying warmth from Asia toward the Americas. These waves are slow by our standards. A Kelvin wave takes about 2 to 3 months to cross the Pacific, travelling around 10,000 miles from the western warm pool to the coast of South America. Slow, steady, unstoppable. It just keeps rolling east, day after day, week after week. And as it rolls, it does something huge. It carries the deep warm water eastward and shoves the thermocline down beneath it. Remember, off Peru, the cold water normally sits close to the surface, ready to rise and feed the sea. When a Kelvin wave arrives, it presses that cold layer down, deep, out of reach. So when the wave finally reaches South America, the cold pump stalls. The upwelling still tries to pull water up, but now it only finds warm, empty water where the cold richness used to be. The green sea turns blue and clear, and the warmth keeps building at the surface off Peru, exactly where the fishermen 400 years ago first felt it turn. This is the moment the ocean starts to run a fever. The warm water has crossed the whole Pacific, hidden the entire way, and now it surfaces off the Americas and begins to spread. Scientists can track these waves as they travel. They watch them with a network of floating buoys strung across the equator, machines that dangle sensors deep into the water and radio back what they find. So when a big Kelvin wave sets off from the west, forecasters can see it coming and know that warm water is on its way east months before it arrives. This part is measured and confirmed, watched in real time, and in 2026 they have been watching exactly this. Waves of warm water have been rolling east across the Pacific, pushing the cold water down, feeding the growing warmth off South America. The fever is climbing, but the Kelvin waves are only the delivery trucks. The real payload is the heat itself, and a shocking amount of it is not sitting on the surface where satellites can easily see it. It is buried below, a hidden reservoir of warmth loaded deep under the sea, and right now it is bigger than almost anyone outside of science realizes. Below the surface of the Pacific, hidden from every satellite, a vast pool of heat is loaded and waiting to rise. When we talk about El Niño, most people picture warm water on top of the ocean, the part you would feel if you went swimming, but the surface is only the skin of the story. The real fuel is stored deeper down, in a layer of the ocean that no photo from space can show you. Those Kelvin waves we just followed have been carrying warm water east and stacking it up beneath the surface off the middle and eastern Pacific. It piles up at depths of a few hundred feet, well below the waves and the sunlight, in the dark, and there is a lot of it. Right now, in 2026, scientists are measuring this hidden layer, and the numbers are striking. Down at those depths, the water is running far warmer than normal. In some spots, it is close to 10 degrees Fahrenheit above where it should be. 10 degrees may not sound like much for the air outside your window, but for a huge slab of deep ocean, that is an enormous amount of extra heat packed into the water and sitting there like a charged battery. That is exactly the right way to think about it. This buried warm layer is a battery of heat, and a battery is useless until something draws the power out. In the ocean, that power gets drawn up to the surface bit by bit, feeding the El Niño above it, keeping it alive and helping it grow. This buried layer decides what comes next. When forecasters want to know whether an El Niño will get stronger, one of the first things they check is this hidden reservoir. A big pool of buried heat is like a full gas tank. It tells them the event has plenty of fuel left to burn. A thin, weak layer down below would mean the event might soon run out of gas. And in 2026, the tank is full. That deep pool of warmth is large and strong. It has been feeding the surface warmth of South America and giving this El Niño the energy to keep climbing week after week. Scientists have watched that heat move up from the depths and spread across the surface, and they are confident this event still has room to grow. Think of it like a pot of water on a stove. The surface is where you see the steam and the bubbles, but the real story is the burner underneath, quietly pouring heat into the water from below. This buried reservoir is the burner. As long as it stays hot, the pot keeps cooking. This is one reason forecasters are so confident that the current El Niño will strengthen through the rest of the year. It comes straight from measuring that hidden battery of heat and seeing how full it is. The fuel is real, and it is there, right now under the Pacific. But all of this warmth, the surface heat, and the buried reservoir alike, is spread across a truly gigantic ocean. So how do scientists boil it all down into one simple answer, a single number that tells them whether an El Niño is here and how strong it is? They do it by watching one small rectangle of sea, a patch they trust more than any other. And that little box has a strange name. Out in the middle of the Pacific, there is one rectangle of ocean that scientists watch more closely than almost anywhere else on Earth. The Pacific is enormous, far too big to measure all at once. So over the years, scientists picked out a few key boxes of sea along the equator to keep an eye on, and they gave them plain numbered names. The most important one sits in the central Pacific, and it is called the Niño 3.4 region. Do not let the odd name throw you. It is really just a box drawn on the map, a chunk of open ocean along the equator, roughly halfway between Asia and South America. Scientists chose it because the water temperature there does the best job of capturing the whole El Niño story in one place. What happens in this box tends to speak for the entire event. Here is what they do. Every week they measure the surface temperature inside that box and compare it to the normal temperature for that time of year. Then they ask a simple question. Is it warmer than usual, cooler than usual, or right about normal? If the water in that box runs warmer than normal by about 1 degree Fahrenheit, and it stays that way for months. Scientists declare that an El Niño is underway. If it runs cooler than normal instead, that is the opposite event, the cold sister called La Niña. And if it sits close to normal, the ocean is in its everyday balanced state. So this little box works like a thermometer under the planet's tongue. One reading, taken over and over, tells doctors whether the patient has a fever. Scientists watch it the same way, checking that patch of sea week after week, tracking whether the fever is rising or breaking, and the fever is rising. Earlier in 2026, in the spring, the box was running about 1 degree Fahrenheit above normal, just enough to say an El Niño had begun. By early summer it climbed higher. By the middle of July, the reading had jumped to almost 4 degrees Fahrenheit above normal, and it was still going up. Almost 4 degrees above normal across a huge box of open ocean is a serious fever. For a slice of sea that size, that much extra warmth means a powerful event, one strong enough to reach around the world. And because that number was still climbing in the middle of summer, forecasters expect it to grow stronger before it peaks. This is why that one rectangle matters so much. A person cannot watch the entire Pacific at once. But they can watch this single box, trust it, and read the health of the whole system from it. When this box spikes, the planet's weather is about to shift. Everything we have talked about so far, the winds, the warm pool, the hidden reservoir, all of it shows up as that one climbing number in that one patch of sea. The box is where the invisible becomes visible. But water temperature is only half of the machine. El Niño is also a sky event. The air above the Pacific plays its own matching game, rising and sinking, swelling and easing, in perfect step with the water below. And the strange thing is, scientists discovered that part of the puzzle long before they understood the ocean side. More than 100 years ago, one very confused man in India stumbled onto a giant seesaw in the sky, and he could not explain it for the life of him. More than 100 years ago, a British scientist in India set out to solve one problem and accidentally uncovered a giant seesaw in the sky. His name was Gilbert Walker. He worked for the Weather Service in India in the early 1900s, and he had one job that mattered above all others. He was supposed to predict the monsoon, the season of heavy rains that Indian farmers depended on to grow their food. When the monsoon came, crops grew and people ate. When it failed, millions could starve. The stakes could not have been higher. Walker was a numbers man. He gathered mountains of weather records from all over the world, air pressure readings, rainfall totals, temperatures, and he started hunting for patterns hidden inside them. He was looking for anything that might warn him, in advance, whether the next monsoon would be strong or weak, and buried in all those numbers he found something odd. He noticed that the air pressure over the Pacific behaved like a seesaw. When the pressure rose high over one side of the ocean, near Australia and Indonesia, it sank low over the other side, near the middle of the Pacific, and when it flipped together. One side up, the other side down, back and forth, year after year. A perfect seesaw stretched across thousands of miles of ocean. Walker gave this back and forth motion a name. He called it the Southern Oscillation. Oscillation is just a fancy word for something that swings back and forth, like a seesaw or a swing set. So the Southern Oscillation was his name for this giant swinging pattern in the pressure of the air over the Pacific. He proved the pattern was real. He showed it swinging in his records, clear as day. He even showed that it was tied to droughts and floods in far apart places, that when the seesaw tipped one way, certain countries dried out while others flooded. But here is where Walker got stuck, and it is worth being honest about it. He could see the seesaw. He could not explain it. He had no idea what was actually making the air pressure swing back and forth across the Pacific. He had found a footprint without ever seeing the creature that made it. Many other scientists doubted him. They thought his seesaw might just be a coincidence hiding in the numbers, a pattern with no real cause behind it. Walker believed it was real, yet he could not point to the engine driving it. He died without ever knowing what powered his own discovery. Walker had half the puzzle in his hands, the sky half, the great seesaw of air pressure. He simply did not have the other half. The other half was the ocean, the warm water, the piled-up warm pool, the tilting thermocline, the whole story we have been building. The air seesaw Walker found and the warm water shift scientists would later measure were two halves of one single machine, joined at the hip. But nobody realized they were connected. For decades, scientists studied the ocean warming off Peru as one thing, and Walker's air pressure seesaw as a completely separate thing. Two teams, two puzzles, working in the dark, never guessing they were staring at the same beast from opposite ends. It would take another 40 years and one sharp mind to finally snap the two halves together and reveal the full monster. And when he did, it changed how we see the planet. In the 1960s, one scientist finally saw that the ocean and the sky were dancing to the same song. His name was Jacob Bjerknes. He looked at the warm water shifting across the Pacific, and he looked at Gilbert Walker's seesaw of air pressure, the two puzzles everyone had treated as separate for decades. And he realized something that now seems obvious but took a genius to see. They were the same thing. Here is what Bjerknes understood. They are one loop feeding each other in a circle. Follow it around. When the warm water spreads east across the Pacific, it heats the air in the Central Ocean and weakens the trade winds. Weaker trade winds let even more warm water spread east. That warms the air further, which weakens the winds even more. Round and round it goes, each part pushing the next, the ocean and the sky locked together, driving each other on. Walker had found the sky half. The ocean scientists had found the water half. Bjerknes clicked them together and showed they were one giant coupled machine, the warm water and the wind seesaw joined as a single system. Because the two halves belonged together, scientists needed one name for the whole thing. They took El Niño, the name from the warm ocean water, and they joined it with the Southern Oscillation, Walker's name for the air seesaw. Put together, it became the El Niño Southern Oscillation. That is a mouthful, so scientists shorten it in speech to a single word that sounds like ENSO. But the long name tells the true story. It is the ocean and the sky, bound into one. Now, why does this loop matter so much? Because a loop that feeds itself can grow. Think about standing on a stage with a microphone. If you point the microphone at the speaker, you get that awful screech. The speaker feeds the microphone feeds the speaker louder and louder until the whole room is ringing. It runs away with itself. Nobody added more sound. The loop just kept amplifying what was already there. El Niño works the same way. A small nudge, a brief weakening of the winds gets caught in the loop. The ocean feeds the sky feeds the ocean, and the whole thing grows far bigger than the nudge that started it. This is why a 2-week windburst can swell into a planet-sized event. The loop does the amplifying. Bjerknes proved this connection, and today it is rock-solid science. Every El Niño scientists have measured since then has followed this coupled dance, the water and the wind driving each other. It is one of the great discoveries in the study of our planet, and it turned El Niño from a local curiosity off Peru into a global force we can actually track and predict. Understanding the loop also unlocks something powerful. Once scientists knew the ocean and sky were linked, they could watch one to forecast the other. Warm water building in the Pacific became an early warning for droughts and floods on the far side of the world, months ahead of time. And here is the first big effect that loop unleashes once it gets going. When the warm water slides east and the winds give way, the rain does not stay where it has always been. The greatest rainstorms on Earth pick themselves up and move. The rain factory that fed Asia is about to change its address. The biggest, most reliable rainstorms on Earth are about to pack up and move thousands of miles. To see why, picture the normal Pacific one more time. Over the warm pool near Indonesia, warm wet air rises, builds huge clouds, and dumps heavy rain. That air travels high across the sky to the eastern Pacific, where it cools and sinks back down. Sinking air is dry air, so off the coast of Peru the sky stays clear and the land stays desert. So there is a giant loop of air here too. Rising and raining in the west, sinking and drying in the east, with high winds connecting the two up top. Scientists call this loop the Walker circulation, named after the same Gilbert Walker who found the seesaw. It is the sky's half of the machine, spinning like a great wheel over the Pacific. This wheel is why the map looks the way it does. Wet, green rainforests near Indonesia, dry desert coasts near Peru. The Walker circulation sets that pattern and holds it in place year after year. Now let El Niño loose and watch the wheel break. When the warm water slides east into the central Pacific, the heat goes with it. And rain always wants to form over the warmest water, because that is where the air rises fastest. So the rising air, the towering clouds, the heavier storms, all of it drifts east, out over the middle of the ocean, following the warmth. The result is a swap. The countries that always got the rain, places like Indonesia, Australia, and the islands nearby, suddenly find the storms have left them. The air over them starts to sink instead of rise. Sinking air is dry air. So these normally soaking wet places dry out, and drought creeps in where rainforests used to drink. Meanwhile, out in the middle of the Pacific and reaching toward the Americas, rain pours down over open ocean and coasts that are usually much drier. Places that rarely see big storms get soaked. The desert coast of Peru, normally bone dry, can suddenly face heavy rain and flooding. Here is a simple way to see it. Imagine a campfire with everyone gathered around it for warmth. Now pick up that fire and carry it to the other side of the yard. The heat, the light, the smoke, all of it moves with the fire. The people left behind in the old spot go cold, while a new patch of yard suddenly gets warm. El Niño picks up the rain factory and carries it east, and whole countries feel the cold spot it leaves behind. This swap is one of the most powerful things El Niño does. It can turn a rainy season into a drought in one country, while drowning another country half an ocean away. All from the same warm water sliding east and dragging the storms along. Scientists see this happen every strong El Niño. It is a confirmed, repeating pattern, measured again and again. The rain moves, and the map of wet and dry redraws itself across the whole tropical Pacific. But the storms do not just rearrange the tropics and stop there. When you dump that much heat and rain into the middle of the ocean, you send a shove high into the atmosphere, and that shove travels. It reaches up into the fast rivers of wind that steer weather across entire continents, including the one you are standing on. A warm patch of ocean is about to change the weather over your hometown. A warm patch of ocean near the equator can change the weather over a city 5,000 miles away, and for a long time that seemed impossible. How could water heating up in the middle of the Pacific reach all the way to North America and shift the storms over a town in the middle of a continent? The answer is one of the most amazing links in all of Earth science, and scientists have a special word for it. They call these long-distance connections teleconnections. The tele part just means far away, like a telephone carrying a voice across a distance. A teleconnection is the ocean sending a message to a faraway place. Here is how the message travels. When El Niño drags all those storms into the central Pacific, it pumps a massive amount of heat high up into the sky. Warm air rises, remember, and over that warm water it rises in enormous towers, punching heat far above the ocean. That rising heat acts like a fist shoved up into the atmosphere. High above the planet there are fast rivers of wind called jet streams. They blow around the globe at the altitude where airplanes fly, moving faster than any car on a highway, and they act like tracks that steer storms across the continents. Where the jet stream goes, the storms follow. It is the great conveyor belt of weather. Now, that fist of heat rising over the Pacific pushes up against the jet stream and bends it. And when the jet stream bends, every storm riding on it gets rerouted. A path that normally carried storms across the northern United States might buckle south. Think of the jet stream as a garden hose lying across the yard, spraying water as it goes. If you nudge the nozzle even a little, the whole stream of water swings and lands somewhere completely different. El Niño is the hand nudging the nozzle. A small push over the Pacific swings the weather far downstream across whole countries. This is the secret to how a Pacific event becomes your weather. The warm water bends the jet stream, and the bent jet stream carries storms to new places. Rain shows up where it usually would stay dry. Dry spells settle in where rain was expected. Even the cold and warmth of a season can shift, all because a patch of ocean thousands of miles away changed how the air rises. Scientists have mapped these teleconnections carefully. They know, for example, that a strong El Niño tends to steer more storms and moisture across the southern United States, and tends to leave parts of the north warmer and drier. These patterns are confirmed, seen over many events, though the exact details shift from one El Niño to the next. This is why the whole world pays attention when that little box in the Pacific starts to warm. It always reaches far beyond the ocean itself. Through these invisible threads in the sky, one warm patch of sea ties itself to farms, cities, and coastlines across the planet. And right now, in 2026, that warm patch is not small, and it is not fading. It is large, it is strong, and it is still growing. The threads are already being pulled. So the real question stops being whether this reaches you. It becomes how big this event is going to get. And to answer that, we need to look at exactly where things stand today. This is happening right now, in 2026, as you listen. It is live, unfolding under the Pacific this very moment. Let's put the pieces together with the real numbers scientists are tracking today. Earlier this year, the trade winds across the Pacific weakened, just as the whole process needs them to. Warm water began sliding east. Kelvin waves rolled across the ocean, pushing the cold water down and feeding warmth towards South America. The buried reservoir of heat filled up, and that key box of C, the one scientists watch above all others, started to climb. Here is how the fever rose. In the spring, the box was running about 1 degree Fahrenheit above normal, enough to officially declare that an El Niño had begun. By June, it had climbed higher. By the middle of July, the reading reached almost 4 degrees Fahrenheit above normal, and it was still rising as summer went on. Because of all this, the main weather agency in the United States raised what they call an El Niño advisory. That is their official way of announcing to the world that El Niño is here, it is real, and people should start paying attention. Scientists are confident and clear. El Niño is present, and it is getting stronger, and they expect it to keep growing. Forecasters put the odds that this event lasts into early 2027 at around 97%. 97 out of 100. In the world of weather forecasting, where surprises are common, that is about as close to a sure thing as scientists ever say out loud. They are confident because they can see the fuel, that full reservoir of buried heat, still waiting to surface. So everything we have talked about, the winds, the warm pool, the hidden waves, the tilting thermocline, all of it has actually happened this year. This is a live report on an event reaching right now toward the weather where you live. Think of it like watching a gauge climb into the red and knowing it has not peaked yet. That is where we stand. The patient has a fever, the fever is rising, and the doctors are certain it will get hotter before it breaks. What does a rising El Niño mean for the months ahead? A warmer world, on average, is one of the surest bets. El Niño tends to nudge the whole planet's temperature up because all that heat pouring out of the Pacific has to go somewhere. Rain patterns shift, some places wetter, some places drier, following the bent jet stream, and storms get rearranged, including the big ones that form over the ocean each year. But here is the part that turns worry into real alarm. This El Niño is strong, and it is flirting with a line that only a handful of events in modern history have ever crossed. There is a level where an ordinary strong El Niño becomes something scientists talk about in a lower, more serious voice. They have a nickname for the events that cross that line. They call them Super El Niños, and in 2026 the forecasts keep inching this one toward that title. To understand why that word scares the people who study this for a living, we need to look at what separates a normal El Niño from a true monster, and how close we really are to unleashing one. Some El Niños grow into something the scientists who study them describe in a hushed, careful voice. They call them Super El Niños. Most El Niños are mild. The box of C warms up by a degree or two above normal, the weather shifts a little, and the event fades without most people ever noticing. But once in a long while, the warming does not stop at a degree or two. It keeps climbing. When that central box of ocean runs more than about 3.5 degrees Fahrenheit above normal, scientists reach for a stronger word. That is the rough line where a strong El Niño crosses into super territory, a monster-class event. That may still sound like a small number. 3.5 degrees across a patch of ocean hardly seems like the stuff of disasters. But remember what we have learned. This is an average across a gigantic box of sea, and every bit of that extra warmth pumps more heat into the sky, bends the jet stream harder, and shoves the world's weather further from normal. A little more warmth in that box means a lot more chaos spread across the planet. Super El Niños are rare. In modern records going back many decades, only a small handful have ever reached that level. They are the events people still talk about years later, the ones that broke records and reshaped seasons around the world. When one shows up, it tends to leave a mark on history. So where does 2026 stand? Right on the edge, and leaning toward the monster side. The forecasts this year are striking. Scientists give high odds that this becomes a strong El Niño, and they see a real serious chance that it climbs all the way into super territory. Some of the computer models push even further, hinting at a very strong event. One major world weather agency has suggested that in certain parts of the tropical Pacific the warmth could climb past 5 degrees Fahrenheit above normal at the peak. That would put this event among the heavyweights. Now, an honest word about certainty. These are forecasts, and the ocean can still surprise everyone. El Niño might peak strong and stop just short of the monster line, or it might barge right across it. Scientists are watching closely and updating their outlooks every month, and they will tell you plainly that the exact peak is still uncertain. What they are confident about is the direction. This event is strong, it is growing, and it has a real shot at greatness of the frightening kind. Why does that word super make experienced scientists lower their voices? Because they remember what the last few monsters did. They remember flooded deserts and burning forests, crashed fisheries and record heat, whole seasons knocked sideways across the globe. A Super El Niño is a planet-scale event that can touch billions of lives at once. So the stakes for the months ahead ride partly on one question. Does this event stay merely strong, or does it cross that line into the monster class? To understand what is truly at risk if it does, we have to go back in time. We have to visit the first great modern monster, the one that caught the entire world off guard, blindsided the scientists themselves, and taught humanity to take this warm little patch of ocean deadly seriously. The year was 1982. In 1982, the ocean did something so big that the scientists watching it almost missed it entirely. An enormous El Niño was building in the Pacific, one of the strongest anyone had ever seen. In the eastern part of the tropical Pacific, the water climbed to shocking levels, running as much as 20 degrees Fahrenheit above normal in places. A heat spike far beyond what most scientists thought was even possible. And here is the part that should send a chill down your spine. They nearly failed to see it coming. Back then, in the early 1980s, scientists leaned heavily on satellites to measure the temperature of the sea from space. But that same year, a huge volcano called El Chichon erupted in Mexico and blasted a veil of ash and haze high into the sky. That haze fooled the satellites. It made the ocean look cooler than it truly was, hiding the monster that was growing underneath. So the very tools meant to warn the world were blinded at the worst possible moment. By the time scientists pieced together what was really happening, the giant was already loose, and it went on a rampage across the planet. On one side of the Pacific, Australia and nearby countries dried out and caught fire. Brutal drought cracked the land and wildfires tore through it. On the other side, the deserts of Peru and Ecuador, normally bone dry, drowned under torrents of rain. Rivers swelled and burst. In one case, a whole village sat at the meeting point of 2 rivers until the floods and mudslides of that year swept it away and left nothing behind that people could live in. The chaos did not stop at the tropics. The west coast of North America was battered by storm after storm through the winter. And out at sea, the warm water starved the fisheries from South America all the way up toward Alaska, sending the little silver anchovies and the creatures that fed on them into collapse. Add it all up, and this single event caused billions of dollars in damage and took thousands of lives around the world. All from one warm patch of ocean that had grown out of control while the world looked the other way. That was the wake-up call. Before 1982, many scientists still thought of El Niño as a mostly local affair, a problem for Peruvian fishermen and little more. This event shattered that idea. It proved, beyond argument, that El Niño was a global force capable of reaching into nearly every corner of the planet at once. So the world got serious. After that disaster, scientists began building a real early warning system, stringing lines of buoys across the equator to watch the ocean directly, so no volcano or blind spot could ever hide a monster from them again. Much of the technology forecasters rely on today was born out of the shock of 1982. In a strange way, that monster taught us how to see. This is confirmed history, measured and recorded and studied ever since. 1982 is the event that turned El Niño from a curiosity into one of the most closely watched forces on Earth. But as fierce as that monster was, it was only the first of the modern giants. 15 years later, an even bigger one came roaring across the Pacific, and this time, the whole world was watching, wired up and ready, as it delivered a year so strange that people started calling it the year without a winter. 18 through 33. Same voiceover style, grounded in the record and in the 2026 outlook. This finishes the full 33. 15 years after the first great monster, an even bigger one came roaring across the Pacific, and this time the whole world was watching. The year was 1997. By then, scientists had strung their lines of buoys across the equator, exactly as they had promised themselves after 1982. So when the warm water began to surge, they saw it coming. For the first time in history, people tracked a giant El Niño from its very first stirrings all the way to its peak. Nothing hid this one, and it was enormous. The warmth in the Pacific climbed to record levels, matching and in some ways beating the monster of 1982. Scientists watched their instruments light up and knew a huge event was bearing down on the planet. The effects were staggering, and they wore a different face in every country. In the United States, that winter turned strange and mild across the middle of the country. Places that expected snow and bitter cold got warmth and calm instead. People started calling it the year without a winter. Meanwhile, California got soaked. Storm after storm rolled in off the Pacific, dumping heavy rain, flooding roads and triggering mudslides down soggy hillsides. Across the ocean, the pattern flipped. Indonesia, Malaysia and the Philippines dried out under harsh drought. The forests there grew so dry that fires broke out and burned out of control, filling the sky with smoke, and down in Peru the desert coast drowned again under torrents of rain, just as it had in 1982. There was one city that told the whole story in a single number. Piura sits in the desert of northern Peru, a place so dry that in a normal year it barely sees rain at all. During these giant El Niño events, Piura was hit so hard that the rain in one season added up to about the same as its 40 rainiest normal years combined. Imagine 40 years of rain falling in a matter of months onto a city built for a desert. The streets became rivers. Add it all up, and this event caused billions of dollars in damage around the world. It struck farms, cities, coastlines, and fisheries across the planet. For Peru alone, the losses ran into a large slice of the country's entire yearly income. One warm patch of ocean reached into the wallets and homes of people on every continent. But here is what made 1997 different from every event before it. This time, humanity was not blindsided. Because scientists had watched it build, they could warn people in advance. Governments prepared, farmers adjusted, emergency crews got ready before the floods came. The early warning system born from the shock of 1982 proved that it worked. Lives were saved because for the first time the world could see the monster approaching. This is confirmed history, measured live, and studied ever since. 1997 is the event that proved we could not just fear El Niño, but forecast it and act. Yet even that giant was not the end of the story. Nearly 20 years later, another huge El Niño arrived, and it did something the others had not. It helped push the entire planet to the hottest it had ever been in recorded history, and it left the ocean's most colourful cities of life bleached white and dying. In 2015, a giant El Niño helped shove the whole planet to the hottest it had ever been in recorded history. By this point, scientists had decades of practice watching these events. The buoys, the satellites, the computer models, all of it was sharper than ever. So when a powerful El Niño built through 2015 and into 2016, forecasters saw it clearly and braced the world for what was coming. This event stood shoulder to shoulder with the monsters of 1982 and 1997. The warmth in the Pacific climbed to towering levels, and it arrived at a moment that made everything worse, because the planet as a whole had already been warming for decades. The El Niño heat stacked on top of that. The result was a record. 2016 became, at the time, the hottest year humanity had ever measured. All that heat pouring out of the Pacific spread through the air, lifted temperatures around the globe and pushed the world past a line it had never crossed before. It was a clear, measured signal that El Niño can do more than shift rain from one country to another. It can turn up the temperature of the entire planet, and the damage reached into places most people never see. Out in the tropical seas, the warm water crept over the coral reefs, the bright, crowded cities of life beneath the waves. Warm water is poison to coral if it lingers too long. Across the world's oceans, reef after reef began to turn a ghostly white, a warning sign that the coral was in deep trouble. It became one of the largest coral bleaching events ever recorded, striking reefs on nearly every side of the globe at once. On land, the story was drought and flood. the familiar El Niño signature written large. Some regions dried out and lost their crops, others flooded, water supplies were strained, farmers struggled, food prices moved. The event rippled through the daily lives of millions of people who had never heard the words El Niño in their lives. Here is a way to grasp the scale. Think of the planet as a single patient with a temperature. Most years, that temperature wobbles up and down by tiny amounts. A strong El Niño is like the patient spiking a fever on top of a body that was already running warm. 2016 was that spike, and it set a record that stood as a warning of what these events can do when they land on an already heating world. Scientists are certain about this connection. They have measured, again and again, that big El Niño years tend to be the hottest years. The heat comes straight out of the Pacific and into the global average. This is confirmed, tested, and repeated across event after event. That is why the current El Niño, the one growing right now in 2026, has so many scientists watching with sharp attention. They have seen this movie before. They know that a strong event landing on a planet that is warmer than it was in 2016 could push the record even higher. But before we look at where this one is heading, we need to go down into the water and truly understand one of the quietest tragedies El Niño causes. We need to see exactly why a few degrees of warmth can turn a reef bursting with colour into a silent white graveyard. A coral reef is a living city, and El Niño can turn it into a ghost town in a matter of weeks. If you have ever seen a healthy reef, you know it is one of the most crowded, colourful places on Earth. Fish of every colour dart through it. The coral itself glows in reds, golds, purples and greens. Reefs cover only a tiny sliver of the ocean floor, yet a huge share of all sea life depends on them for food and shelter. They are the rainforests of the sea. Here is the secret that keeps them alive. Coral is an animal, but it shares its home with tiny plants that live right inside its body. These little plants use sunlight to make food, and they hand most of that food to the coral. In return, the coral gives them a safe place to live. It is a perfect partnership, and it is also where the coral gets almost all of its bright colour. The plants are the paint. Now bring in the warm water. When El Niño pushes the ocean temperature up and holds it there, the coral gets stressed, the same way you feel sick in a heat that will not break. Under that stress, the coral does something drastic. It kicks out the tiny plants living inside it, and the moment those plants leave, the colour goes with them. The coral turns bone white. Scientists call this bleaching, because the reef looks like it has been drained of all its paint. Picture a bright, bustling city where suddenly every light goes dark and everyone leaves. The buildings still stand, but nothing lives there anymore. That is a bleached reef. Still there in shape, but emptied of its glow. A bleached coral is not dead yet. If the warm water backs off quickly, the tiny plants can move back in, the colour can return, and the coral can recover. That is the hopeful path. But if the heat lingers, week after week, the coral starves without its plant partners feeding it, and it dies for good. When enough coral dies, the whole city collapses. The fish lose their homes. The creatures that ate those fish go hungry. The reef falls silent. This is why scientists watch coral so closely during a strong El Niño. The reefs are like a living warning light. When they start turning white across wide stretches of ocean, it tells us the sea has crossed into dangerous heat. During the giant event of 2016, reefs bleached on nearly every side of the planet at once, in one of the worst episodes ever recorded, and this is confirmed, not guesswork. Scientists have watched reefs bleach in real time, tracked the water temperatures that caused it, and followed which reefs recovered and which ones died. The link between El Niño warmth and coral bleaching is proven and clear. So as the current event grows through 2026, the reefs are once again in the danger zone. A strong El Niño landing on already warm seas is exactly the recipe that turns living colour into white silence. The coral is the quiet victim. But El Niño also strikes at something far more direct, something that touches human dinner tables and whole national economies. It reaches back to that same cold Peruvian coast where our story began, and it empties the greatest fishery on Earth. The greatest fishery on the planet can empty out in a matter of weeks, and El Niño is the reason. Come back to the coast of Peru, where our whole story started. Remember the cold, rich water that rises up from the deep and feeds the tiny plants, which feed the little silver anchovies, which feed nearly everything else. In a good year, that cold water builds one of the largest catches of any single kind of fish anywhere on Earth. Fishermen there have pulled up around 10 million tons of anchovies in one season. 10 million tons from one strip of coast. Those anchovies matter far beyond Peru. Much of that catch gets ground into feed that helps raise chickens and farmed fish all over the world. So a fish caught off South America can end up feeding animals and people on continents thousands of miles away. The whole thing rests on one thing staying true. The water has to stay cold. Then El Niño arrives and the cold shuts off. You already know the mechanism. The warm water slides east across the Pacific. The Kelvin waves push the cold layer deep, far below the surface. The upwelling pump tries to work, but now it only pulls up warm, empty water with no fertilizer in it. The tiny plants starve, and when the plants at the bottom of the food chain vanish, the anchovies have nothing left to eat. So the anchovies flee. They swim away in search of cooler, richer water, or they simply die off in huge numbers. The clouds of silver fish that fill these waters thin out and disappear. The green, life-filled sea turns clear, blue, and empty. For the fishermen, it is a disaster that comes fast and hits hard. During the giant event of 1997, the catch off Peru crashed by around 80%. Imagine going to work and finding that 4 out of every 5 things you rely on to make a living have simply vanished. Whole fishing towns are thrown into crisis. Boats stay tied to the dock. Families that fed themselves for generations suddenly cannot, and it does not stop at the fishermen. Peru's economy leans heavily on this catch. During the biggest El Niño events, the country has lost a large slice of its total yearly income, wiped out by the collapse of the fishery and the floods that come with it. One warm patch of ocean can shake an entire nation's finances. Here is a simple way to see it. Picture a giant factory that never stops running, turning out food day and night, feeding animals across the world. Now imagine someone quietly switching off the power. The machines still stand there, but nothing comes out. El Niño is the hand on that switch, and the cold water is the power. This is confirmed, measured history. Scientists and fishermen alike have tracked these collapses through event after event. When the cold fails, the fish fail, and the numbers prove it every time. But the anchovies are only the first domino to fall. When billions of little fish vanish from the sea, everything that ate those fish is suddenly starving too. And some of the most dramatic victims are not down in the water at all. They are the animals that live on the fish, the birds and the beasts of that coast. When the anchovies disappear, the sky and the shore fall silent too. When the little silver fish vanish, the beaches fill with the starving and the dead. Think about everything that depends on those anchovies off Peru. It is not just the fishermen. For millions of years, before any human ever cast a net there, the anchovies fed a whole world of wild animals, vast flocks of seabirds, colonies of seals and sea lions basking on the rocks, even some of the great whales that pass through. All of them, in one way or another, are built on the backs of those little fish. In a normal year, this coast roars with life. Seabirds crowd the cliffs by the hundreds of thousands, diving into the water in great feeding frenzies. Sea lions haul out on the rocks, fat and loud. The air is full of wings and calls. It is one of the busiest wildlife scenes on the whole planet, all fueled by the cold, rich water and the fish it feeds. Then El Niño empties the sea, and the roar goes quiet. The seabirds fly out over the water and find nothing. The fish they need are gone, chased away or dead. So the birds fly farther and farther, searching burning energy they cannot replace. Many simply do not make it back. Their chicks, waiting in the nest for a meal that never comes, starve. During strong events, seabird numbers along this coast can crash, sometimes falling by huge fractions in a single season. The sea lions face the same nightmare. Mothers must swim out to catch fish and bring energy back for their pups. But when the fish disappear, the mothers come back with nothing, or they do not come back at all. The pups on the beach grow thin and weak. In the hardest El Niño years, the shores can become a heartbreaking scene, dotted with young animals that could not find enough food to survive. Here is a way to feel the scale of it. Picture a giant apartment building where thousands of families all get their groceries from a single store downstairs. Now imagine that store closing overnight, with no warning and nowhere else to shop. That is what El Niño does to this coast. It shuts the one store that an entire wild community depends on, all at once. And this ripples outward. When the birds and the seals crash, it changes the whole living balance of the coast for years afterward. Populations that took decades to build can be knocked down in months. Some recover when the cold water returns and the fish come back. Others take a very long time to heal. The event leaves a scar on the wildlife long after the water has cooled. This is confirmed, watched, and recorded. Scientists have counted the birds and the seals through El Niño after El Niño, and the pattern holds. When the anchovies fail, the food web above them fails too. It is one of the clearest examples anywhere of how a shift in the ocean can reach all the way up to the animals we can see with our own eyes. So El Niño starves the sea and the shore. But it does not stop at hunger. On this same desert coast, the very same event brings the opposite kind of disaster crashing down from the sky. While the fish are vanishing, the rain is coming. And in a place built for dryness, that rain becomes a flood of biblical size. There are deserts on Earth so dry that a hard rain can destroy them, and El Niño brings exactly that kind of rain. Return one last time to the coast of Peru, but now look at the land instead of the sea. Much of this coast is desert, some of the driest ground anywhere on the planet. In a normal year, the sky here stays clear. The people build their homes, their roads, and their towns for a world without rain. Flat roofs, dirt streets, dry riverbeds that have not run in years. Everything is shaped by the expectation that water simply does not fall from the sky here. That works until El Niño flips the switch. Remember what happens when the warm water pools off this coast. The air above it heats up, rises, and forms towering storm clouds where there are almost never storm clouds at all. The rain factory, which normally lives far away over the western Pacific, moves right overhead. And it opens up on a land that has no idea what to do with water. The results are almost hard to believe. Take the desert city of Piura in northern Peru. In a normal year, it barely sees rain. But during the giant events of the past, the rain that fell there in a single season added up to roughly the same as its 40 rainiest ordinary years combined. 40 years of rain poured onto a desert city in a matter of months. Picture what that does. The dry riverbeds that had been quiet for years suddenly roar back to life, filling with brown, churning water. Streets turn into rivers. Flat roofs built to shed sun instead of rain, cave in or leak. Mud slides down the bare desert hills because there are few plants to hold the soil in place. Whole neighborhoods can be swallowed. In past events, entire villages sitting where rivers meet have been washed clean off the map, leaving nothing behind that people could rebuild on. Here is a comparison that makes it real. Imagine a house built in a place where it never rains, so no one ever bothered with gutters, drains, or a sloped roof. Now imagine standing in that house while a fire hose is aimed at the ceiling for weeks. Everything the house was built to ignore comes crashing in. That is a desert meeting an El Niño flood. And the human cost is heavy. Homes destroyed, roads and bridges washed out, cutting towns off from help, crops drowned in the fields, disease spreading through standing water. The floods can strike the very same season that the fishery collapses, so families lose their catch and their homes in one blow. It is a double disaster, hunger and flood arriving together. This is confirmed history, recorded again and again. Scientists have traced these floods directly to the warm water offshore. When the sea heats up here, the desert drowns. The link is proven and clear, so one warm patch of ocean starves the sea, silences the wildlife, and drowns the desert, all at once, all in the same place. It is a stunning demonstration of how much power sits in that shifting water. But everything we have seen so far has been on one side of the Pacific, the eastern side near the Americas. Now we have to cross to the other side of the ocean, because while the deserts of Peru are drowning, the green wet lands near Asia are doing the exact opposite. They are drying out, cracking open, and catching fire. On the far side of the Pacific, while the deserts of Peru drown, the rainforests of Asia dry out and burn. This is the strange split personality of El Niño. It does not bring the same weather everywhere. It takes rain from one side of the ocean and dumps it on the other. So at the very moment Peru is flooding, the wetlands near Indonesia and Australia are gasping for water. You already know why. The rain factory that normally sits over the warm pool near Asia picks up and moves east during El Niño. When it leaves, the air over Indonesia and northern Australia starts to sink instead of rise. Sinking air is dry air, so the rain that these places count on month after month simply stops coming. For lands that are used to being soaked, this is a shock. The rainforests of Southeast Asia are some of the wettest places on the planet. Australia has vast stretches of farmland and bush that depend on seasonal rains. When El Niño pulls those rains away, the ground dries, the rivers shrink, and the plants that are built for constant moisture begin to wither. Then comes the fire. A rainforest is normally too wet to burn. The trees, the soil, the fallen leaves, all of it holds water like a sponge. But strip that water away during a strong El Niño, and the forest turns into fuel. In places like Indonesia, the ground itself can catch. Much of the soil there is made of ancient packed plant material that holds huge amounts of carbon, and when it dries out it can smoulder and burn for weeks, sending up thick clouds of choking smoke. During past strong events, these fires have grown so large that the smoke spread across whole countries, turning day into a hazy gloom and making the air dangerous to breathe for millions of people. Farms failed. Crops that needed the rain never grew. Water supplies ran low. Australia, in some El Niño years, has faced brutal drought and dangerous fire seasons tied straight back to the warm water in the Pacific. Here is a comparison to hold on to. Imagine a wet kitchen sponge sitting by the stove. Soaked, it will never catch fire, but leave it out to dry completely, and now a single spark can set it burning. El Niño is what dries the sponge. It takes the world's wettest forests and turns them into something that can burn. And this matters for everyone, even far away. When these forests and soils burn, they release enormous amounts of gas into the air that traps heat. The same kind of gas that warms the whole planet. So the drought and fire on one side of the Pacific can feed back into the global warming that makes future events worse. The fire is both a symptom and a cause. This is confirmed, measured, and studied. Scientists have tracked the droughts and the fires through El Niño after El Niño, and the pattern holds firm. When the rain moves east, the west burns. So now you can see the full split. One event, drowning deserts on one shore and burning rainforests on the other, at the very same time. But the drought does not stop at Asia and Australia. It can reach across the world to strike another giant green heart of the planet, one that we all depend on more than most people realize. The drought is coming for the Amazon. El Niño can reach across the entire planet and dry out the largest rainforest on Earth. The Amazon is almost too big to picture. It sprawls across a huge part of South America, a sea of green so vast it makes its own weather and helps set the balance of gases in the air for the whole world. It is often called the lungs of the planet, because its countless trees breathe in the gas that traps heat and breathe out the oxygen we need. When the Amazon is healthy, it helps keep the whole Earth in balance, and El Niño can put it under serious stress. During a strong event, the shifted weather patterns tend to steer rain away from large parts of the Amazon. The forest, which normally drinks deeply from frequent rains, suddenly finds the sky going quiet. Rivers that are usually wide and deep can shrink. Some stretches drop so low that boats, the main roads of the rainforest, cannot pass. Communities that rely on the rivers for travel, food and water find themselves cut off. As the drought deepens, the forest itself begins to suffer. Trees that are built for constant moisture grow stressed, the ground dries, and just as in Asia, a dry rainforest becomes a rainforest that can burn. Fires that would normally sputter out in the damp can instead spread through the parched trees, sending smoke across huge areas and killing patches of forest that took centuries to grow. Here is why this should matter to every single person listening, no matter where they live. The Amazon stores a staggering amount of carbon in its trees and soil. As long as the forest stands, that carbon stays locked away out of the air. But when drought and fire kill large sections of it, that stored carbon gets released into the sky, where it traps more heat and helps warm the whole planet further. So think of the Amazon as a giant vault, holding back an enormous amount of the gas that heats the Earth. A healthy, wet forest keeps the vault sealed. A strong El Niño can crack it open, letting some of that heat-trapping gas escape. The drought in one rainforest becomes a problem for the climate of the entire world. Picture a huge dam holding back a lake. As long as the dam stands, the water stays put and everything downstream is safe. But start to weaken that dam, and the trouble spreads far beyond the dam itself. The Amazon works like that for carbon. El Niño is one of the forces that constrain the wall. This connection is real and studied, though scientists are careful to say the details vary from event to event. Not every El Niño hits the Amazon the same way, and the exact reach of the drought can differ. But the pattern, that strong events tend to dry and stress the forest, is well supported by what researchers have observed. So now the picture is truly global. One warm patch of ocean, drowning deserts, starving fisheries, bleaching reefs, burning Asian forests and drying the great Amazon, all from the same shift in the Pacific. Its arms reach into every corner of the planet, and now, at last, we turn those arms toward home, toward the United States, and toward the season directly ahead. Because this same El Niño is about to change the American summer and fall in ways that start with one of the most powerful forces in nature. It is about to reach into the season of the hurricanes. The same warm water heating the Pacific can reach across a continent and choke the life out of a hurricane before it ever forms. Hurricanes are among the most powerful storms on Earth. They are born over warm ocean water, usually in the Atlantic during the summer and fall, and they can grow into spinning giants hundreds of miles wide. When one slams into a coast, it can flood cities, tear apart homes, and cost billions of dollars. Every summer, people who live near the Atlantic watch the ocean nervously, wondering how bad the season will be. Here is the surprising part. A strong El Niño, thousands of miles away in the Pacific, tends to protect the Atlantic coast from these storms. It acts like a shield. To understand how, you need to know one thing hurricanes hate. They hate high winds up above them that blow in a different direction from the winds down below. When the wind up high pushes one way and the wind down low pushes another way, it tears at the storm and pulls it apart before it can organize. Scientists call this difference in winds by height wind shear. Strong wind shear is like a giant pair of hands ripping the top off a growing storm. Now here is the link. When El Niño heats the Pacific and bends the jet stream, one of the things it does is crank up the wind shear over the Atlantic. It fills the sky above the hurricane zone with those tearing mismatched winds. So when a young storm tries to spin up and grow tall, the shear rips it apart. On top of that, El Niño tends to bring more sinking, stable air and higher pressure over the Atlantic, which makes it even harder for storms to build. The result in most El Niño years is fewer Atlantic hurricanes, and often weaker ones. The shield goes up, and this is exactly what forecasters expect for the season ahead in 2026. With El Niño strong and growing, the outlook calls for a quieter than usual Atlantic hurricane season. Official forecasts have leaned toward a below-average year, with a good chance of fewer named storms than normal. One respected forecast pointed to only around 11 named storms, a modest number for the Atlantic. The reason, again and again, comes back to that rising wind shear driven by the warm Pacific. Picture trying to build a tall tower of blocks while someone keeps swiping their hand across the top. Every time you get a few blocks up, the hand knocks them down. That hand is the wind shear, and El Niño is the one moving it. The storms simply cannot get tall. This is confirmed, well-studied science. Scientists have tracked the link between El Niño and quieter Atlantic seasons across many years. It is one of the most reliable fingerprints these events leave on American weather. Now, a fair and honest word, quieter does not mean silent. A below-average season can still produce a dangerous storm, and it only takes one landfall to cause a disaster, so the shield lowers the odds. It does not switch off the risk. People along the coast still need to stay ready. But here is the twist that makes El Niño so fascinating. While it is busy choking hurricanes in the Atlantic, it is doing the exact opposite on the other side of the country. Over in the Pacific, the same event that calms one ocean is winding the other one up. While El Niño calms the storms in the Atlantic, it winds up the storms in the Pacific. This is one of the strangest tricks in the whole story. The very same event at the very same time can push hurricane activity down on one side of a country and push it up on the other. The Atlantic gets quieter. The eastern Pacific, off the west coast of Mexico and out toward Hawaii, often gets busier. Why the split? It comes down to how El Niño changes conditions in each ocean. In the Atlantic, we saw that El Niño raises the wind shear, those tearing high winds that rip storms apart. But over in the eastern Pacific, El Niño tends to do the reverse. It calms the wind shear there, giving storms a smoother path to grow. And it warms the surface water, which is the fuel that hurricanes feed on. More fuel, less tearing. That is a recipe for more storms and stronger ones. So the same warm water that starves Atlantic hurricanes ends up feeding Pacific ones. It is like a seesaw. Push one side down and the other side rises. El Niño tips the balance of the storms from one ocean to the other. Here is a way to picture it. Imagine two campfires. one on each side of a yard, and a single person controlling the wind between them. On the Atlantic side, that person fans harsh, choppy gusts that scatter the flames and keep the fire small. On the Pacific side, they block the rough wind and add dry fuel, letting the flames leap higher. Same person, opposite results, at the same moment. El Niño is that person standing between the two oceans. For the Eastern Pacific, this can mean a lively hurricane season. More storms spin up off the coast of Mexico. Some track out to sea and fade harmlessly, but others can bring heavy rain and wind to Mexico's coast, or send moisture and storm remnants drifting toward the southwestern United States. Even Hawaii can face a higher risk during strong El Niño years, as more storms roam that part of the ocean. This matters for the season ahead in 2026. With El Niño strong and growing, forecasters expect the Eastern Pacific to run more active than a typical year, even as the Atlantic runs quieter. So the storm risk does not vanish, it moves. It shifts from one coastline to another, following the changes El Niño makes in each ocean. This is confirmed, studied science. Scientists have watched this Atlantic quiet, Pacific busy pattern play out across many El Niño years. The seesaw is real, and it shows up again and again. And it teaches an important lesson about El Niño. This event does not simply make weather better or worse everywhere at once. It rearranges weather. It takes storms, rain, and heat, and moves them from one place to another, so that one region's relief is another region's risk. To understand what El Niño means for you, you have to know which side of its many seesaws you're standing on. So let's bring it all the way home now. Forget the distant oceans for a moment and think about the ground under your own feet, across the United States, in the months right ahead. Because El Niño is about to redraw the map of American weather, deciding where it turns wetter, where it turns drier, and where it turns dangerously hot. Right now, El Niño is quietly redrawing the weather map of the United States for the season ahead. We have travelled across the whole planet in this story, from Peru to Indonesia to the Amazon. Now we land at home. Because the same warm water in the Pacific reaches into the United States and reshapes where the rain falls, where the ground dries, and where the heat builds. And the pattern it draws is uneven. It helps some places and stresses others. Start with the rain. During a strong El Niño, the bent jet stream tends to steer more storms and moisture across the southern part of the country. The southern states, from parts of Texas and the Gulf Coast across the south, often see a wetter pattern. For places that have been stuck in drought, that extra rain can be a welcome relief, refilling dry soil and easing the strain on water supplies. The southwestern California can catch more storms too, which can help recharge parched land. But the same event that soaks the south often leaves the north drier. The northern states and the Pacific Northwest tend to run drier and warmer during a strong El Niño. Rain that those regions usually count on can stay away, and warmth can build in its place. So one part of the country gets a drink while another part goes thirsty. Then there is the heat, and this is where the season ahead gets serious. Forecasters expect above normal warmth across a large stretch of the United States this year, with heat favoured across a big share of the states. When you stack El Niño's warmth on top of an already warming climate, you get a summer and fall that lean hot for many millions of people. Here is an honest and important detail. El Niño's grip on the United States is usually strongest in winter and a bit looser in summer, so its summer effects are real, but a little softer than its winter ones. That means other things still matter a lot in the near term, especially the way the high-altitude winds settle from week to week. When those winds lock into a certain shape, they can park a dome of hot, high pressure over a region and bake it for days. Where and when that happens is one of the hardest things to predict, even a couple of weeks out. Picture the country as a giant table, and El Niño as a hand tilting it. Tilt it one way, and water, meaning rain, rolls toward the south. The north ends up dry. Heat pools in the low spots. El Niño is that tilt, gentle but steady, nudging the whole nation's weather in a certain direction for months at a time. This is confirmed, well-studied science, though scientists are careful to call these tendencies, not guarantees. Every El Niño is a little different, and local weather can still surprise everyone. What forecasters can say with confidence is the overall lean. Wetter south, drier north, and widespread warmth. So this is what El Niño means for your summer and fall, right where you live. Relief for some, strain for others, and heat for many. But zoom back out one more time, because there is a bigger number hiding behind all of this. When you add up El Niño's heat across the entire globe, it does something to the planet as a whole. It reaches up and nudges the thermostat of the whole Earth. Add up all of El Niño's heat across the whole planet, and it does something remarkable. It turns up the temperature of the entire Earth. We usually think of El Niño as moving heat around, taking it from the deep Pacific and spreading it across the surface, shifting rain from one country to another. But there is a bigger effect hiding underneath all of that. During a strong El Niño, the planet as a whole runs warmer. Not just one region. The global average temperature of the entire Earth ticks upward. Here is why. Normally, a huge amount of heat stays locked away in the deep ocean, hidden below the surface where it does not warm the air. Remember that buried reservoir of warmth we talked about? The hidden battery under the Pacific. During a strong El Niño, a big share of that stored ocean heat gets released up to the surface and out into the atmosphere. Heat that was sleeping in the deep suddenly wakes up and joins the air. When that happens across a patch of ocean as vast as the tropical Pacific, it adds up to a lot. The extra warmth spreads through the atmosphere, riding the winds, until it shows up in temperature readings all over the globe. The whole planet feels a little hotter, all at once. This is why the hottest years in the record books tend to be El Niño years. The event acts like a booster shot of heat on top of whatever the planet was already doing. The giant El Niño of 2016 helped make that year the hottest ever measured at the time. It was a clear signal that these events can move the temperature of the entire world. Think of the planet as a giant swimming pool that is very slowly warming year after year from other causes. Most of the time that warming is gentle and hard to notice from one moment to the next. Then a strong El Niño comes along, and it is like someone dumping a load of warm water into the pool all at once. The whole pool jumps up in temperature for a while. That jump is what shows up as a record hot year, and this is confirmed, measured, and repeated. Scientists have tracked global temperatures through El Niño after El Niño, and the pattern holds firm. Strong warm events in the Pacific line up with spikes in the world's average temperature. The connection is one of the most reliable in all of climate science. Now here is the piece that makes the current event so important. The planet today is warmer than it was during the last giant El Niño. Years of steady warming have raised the baseline, the starting point that El Niño builds on top of. So when this event dumps its heat into the atmosphere, it is landing on an already hot world. That raises a serious possibility for what comes next. If this El Niño keeps growing and peaks strong, the heat it releases could push the global temperature to a level the Earth has never recorded before. The booster shot could land on the warmest baseline in human history, which brings us to a stark question about the year directly ahead. Scientists are watching the calendar with real concern, because the way these events work, the biggest temperature spike often does not come during the El Niño's peak. It comes just after, and that timing points straight at next year. The year that could become the hottest ever recorded may be 2027. The hottest year in all of human history might not be this year, it might be next year. That sounds strange at first. If El Niño is growing strong right now, in 2026 you would think this would be the record breaker. But the heat works on a delay, and understanding that delay is the key to what may be coming. Here is how it works. When El Niño releases its stored ocean heat into the atmosphere, that heat takes time to spread around the whole globe and show up in the world's average temperature. The Pacific warms first. Then, over the following months, that warmth works its way through the air, across the continents, into the readings everywhere. So the peak of the ocean warming usually comes near the end of one year, and the peak of the global air temperature comes a bit later, spilling into the year that follows. That is exactly what happened with past giants. A strong El Niño would peak late in one year, and the next calendar year would end up setting the temperature record, riding the leftover heat. The event lights the fuse in one year, and the explosion of heat lands in the next. So follow the timeline for this event. El Niño is growing through 2026 and is expected to peak strong, possibly around the end of the year. If that holds, the heat it releases will spread through the atmosphere and reach its fullest effect in the months after, which points squarely at 2027. That is why scientists are watching next year with such concern. It sits right in the danger zone. And remember the baseline. The planet is already warmer than it was during the last record-breaking event. So this El Niño is loading its heat onto the hottest starting point humanity has ever recorded. Stack a strong El Niño spike on top of that, with the natural delay pushing the peak into the following year, and you have the ingredients for a new all-time record. Scientists put it plainly. If this event materializes as forecast, 2027 would have a strong chance of becoming the hottest year ever measured on Earth. There are already early warning signs. Earlier in 2026, the temperature of the world's oceans hit a new daily record, a hint of just how much heat is already in the system before El Niño even reaches full strength. Picture lighting a long fuse on a firework. You light it in one moment, but the burst comes later, after the flame has travelled all the way down the line. El Niño lit its fuse in 2026. The burst of global heat is timed to arrive in 2027. Now, a careful and honest note. This is a forecast, and forecasts can miss. If El Niño peaks weaker than expected, or fades faster, the record might not fall. Scientists update these outlooks every month and will tell you the exact numbers are still uncertain. What they are confident about is the setup, a strong event landing on a record warm world, with the heat timed to peak next year. The risk is real, even if the outcome is not guaranteed. But this raises a deeper and more unsettling question. El Niño is a natural cycle, older than humanity itself. So how much of this record heat is the natural event, and how much is something we have added on top? To answer that, we have to talk about how El Niño and human-caused warming feed into each other, and why the two together are more dangerous than either one alone. El Niño is a natural force older than humanity, but we have changed the world it acts upon, and that changes everything. For as long as there have been oceans and winds, this cycle has come and gone. Scientists have found its fingerprints in ancient coral, in old tree rings, in layers of mud at the bottom of the sea, going back not just thousands but millions of years. El Niño did not need people. It was flipping the Pacific back and forth long before anyone was here to name it after a child. So El Niño itself is natural. That part is not our doing. But here is the crucial point. El Niño does not act in a vacuum. It acts on whatever world it finds. And the world it finds today is different from the one it acted on a century ago, because we have been warming the whole planet. Think back to the swimming pool. For decades, the world's average temperature has been slowly rising, driven by heat-trapping gases that human activity has poured into the air. This warming raises the baseline, the starting temperature that everything else builds on. It is like slowly turning up the heat under the whole pool, year after year. Now drop a strong El Niño into that warmer pool. The natural event still does what it always did. It releases a burst of ocean heat into the air. But now that burst is landing on top of a baseline that is already the hottest in human history. The same natural spike, added to a higher starting point, reaches heights the planet has never seen before. This is why the two together are more dangerous than either alone. Human warming raises the floor. El Niño adds the spike. Put them together, and you get record after record, each new peak higher than the last. The natural cycle and the human-made warming are not separate stories. They are stacked, one on top of the other. Here is a way to picture it. Imagine a person jumping to touch a high ceiling. El Niño is the jump, a natural temporary burst upward. Human warming is like slowly raising the floor they are jumping from. The jump is the same height it always was, but because the floor keeps rising, the person now smacks into a ceiling they could never reach before. The floor is doing the quiet, steady work. The jump just makes it obvious, and there may be more to it than simple stacking. Scientists are studying whether a warmer world could actually change the nature of El Niño itself, perhaps making the strongest events more common or more intense. This part is still an active area of research, and scientists are careful to say there is real uncertainty here. They do not fully agree yet on how a warming world will reshape the cycle in the long run. It is one of the open questions they are working hard to answer. What they are confident about is the stacking effect. A warmer baseline plus a natural El Niño spike equals higher extremes. That much is well supported and clear. So the record heat that may be coming is a team effort, part ancient natural rhythm, part modern human change. And that mix is exactly why scientists watch these events so closely now. They are not just tracking a curiosity, they are reading a warning about where the whole planet is heading. Which raises the question, how do they watch it? How can scientists possibly keep an eye on something so vast and see it coming months before it arrives? The answer is a hidden machine of buoys and satellites strung across the largest ocean on Earth. Strung across the widest ocean on the planet is a hidden machine that watches El Niño day and night. After the monster of 1982 caught the world off guard, scientists made a promise. Never again would a giant El Niño sneak up on them while their instruments were blind. So they built something remarkable, a network of watchers spread all the way across the tropical Pacific, designed to catch these events in the act. The heart of it is a line of buoys anchored along the equator. Picture floating stations, bobbing on the surface, spaced out across thousands of miles of open ocean. Each one dangles a string of sensors down into the deep, measuring the temperature of the water at many depths, along with the winds up above. Together they take the pulse of the Pacific constantly, and beam that information back to scientists on shore by satellite. This is how forecasters can see a Kelvin wave coming. Remember those giant hidden waves of warm water rolling east beneath the surface? When one passes a line of buoys, the sensors feel the warmth pushing down into the deep, and they send the alert. So scientists can watch that warm water travel across the ocean, station by station, and know it is heading for South America months before it arrives. Above the buoys, satellites add another layer of eyes. From high in space, they measure the temperature of the sea surface across the entire Pacific at once, and they can even sense the slight rise and fall of the ocean's height, which reveals where the warm water is piling up. Between the buoys below and the satellites above, scientists get a full picture, the surface and the depths, all at the same time. Then comes the brain of the operation. All that information gets fed into powerful computer models, machines that use the laws of physics to simulate the ocean and the atmosphere and project them forward in time. The models take today's conditions and run them ahead, month by month, to forecast what El Niño is likely to do next. This is how scientists can say, with real confidence, that an event will grow stronger or last into a certain season. Once a month, on a set schedule, the scientists who watch all of this gather and release an official update to the world. They announce whether El Niño is present, how strong it is, and where they think it is heading. It is like a regular checkup for the health of the Pacific, shared openly so that governments, farmers, and families everywhere can prepare. Here is a way to picture the whole system. Imagine a patient in a hospital, wired up to monitors that track the heartbeat, the temperature, the breathing, all at once, feeding the numbers to doctors who read them and predict what will happen next. The Pacific is the patient. The buoys and satellites are the monitors. The scientists are the doctors, and the monthly update is their report on the patient's condition. This system is real, running right now, and it is the reason we knew this El Niño was coming long before it grew strong. It turned El Niño from a force that ambushed us into one we can see approaching from far off. That warning gives the world time to get ready, and time can save lives and money. And yet, for all this power, the machine still cannot answer every question. There are things about El Niño that scientists, even with all their buoys and satellites and models, still cannot predict. And those remaining mysteries are exactly what makes this force so humbling and so worth watching. For all our buoys, satellites, and computer models, El Niño still keeps secrets that no scientist can crack. We have come a long way in this story. We started with fishermen 400 years ago who thought warm water was just a local curse. We now have a machine spread across the widest ocean on Earth, watching the Pacific day and night, forecasting these events months in advance. That is a stunning leap. And yet, humbling as it is to admit, the mysteries are far from solved. Start with the very beginning of it all, the spark. We understand the loop that makes El Niño grow, the ocean and the sky feeding each other, winding up like that screech from a microphone. But what fires the first shot? What makes the trade winds falter in one particular year and not another? Scientists have ideas, random bursts of wind, the ocean's own slow rhythms, chance lining things up, but they cannot yet reliably predict that first spark far in advance. The trigger remains genuinely uncertain. Then there is the question of strength. Even once an event begins, forecasters cannot say for sure exactly how strong it will get. This year, in 2026, they are confident El Niño is here and growing, and they see a real chance it reaches monster levels. But whether it stops just short of that line or barges right across it is still an open question. The ocean can surprise everyone, and it often does. There is also the matter of El Niño's many faces. It turns out these events are not all the same. Some warm mostly the eastern part of the Pacific near South America, others warm mostly the central part, out in the middle of the ocean. And these different types can send very different weather to different places. Sorting out which kind is forming and what it will do is one of the trickier puzzles scientists are still working on. And looming over all of it is the biggest question of all. How will a warming world change El Niño in the long run? Will the strongest events become more common, more intense? Will the whole cycle shift into something we have never seen? Scientists are studying this hard, and they are honest that they do not fully agree yet. The Pacific is moving into conditions it has not been in before, and even the best models may struggle to keep up with a world that is changing this fast. Here is a way to hold all of this. Imagine you have learned to read the ocean's handwriting well enough to know what it is saying today, and to guess much of what it will say next. But the ocean writes in an old and complicated language, and there are still whole words, whole sentences that you cannot yet make out. We have learned enough to see the danger coming. We have not learned enough to feel in control, and that's exactly why El Niño matters so much right now to everyone. This is not a distant curiosity happening to fishermen on a faraway coast. It is a living force reaching into your summer, your food, your weather, and the temperature of the whole planet you stand on. It is unfolding this very year, growing stronger, tied to a world we ourselves have changed. The little boy the fisherman named is awake again. It is climbing toward its peak. And this time, the whole world is watching, wired up and holding its breath, waiting to see just how far it will go.